In Praise of Antique Books, a meditation on my copy of a 19th century book by Mary Somerville, entitled On the Connexion of the Physical Sciences. I have a small collection of science and technology books from the 19th century. The one I especially treasure has the title On the Connexion of the Physical Sciences, written by Mary Somerville. It's not just for the esteemed author, or the contents which give a fascinating and authoritative summary of astronomy and the physical sciences in the early 19th century, but that my copy has two editions that give it added interest. The first is an inscription by her daughter, Mary. The second is the annotations of an anonymous reader. Conducting a YouTube or web search on her name produces a deluge of hits. Rightly so, for this remarkable woman's contribution to 19th century science education is, to this day, celebrated. Most of the videos centre on her life and times and her ascent to fame in British and European first-rank scientific circles. These are taken as given here. My third edition copy of Connexion has had a hard life. It was published in 1836. The spine of its cover has disintegrated. The adage, "Don't judge a book by its cover," definitely applies here. No doubt to ensure her book's intended popularity, there are virtually no mathematical formulae in the entire book. It's all text and no illustrations. In fact, the absence of any diagrams was heavily criticised by her book's reviewer and friend, Sir David Brewster, in the Edinburgh Review, April 1834. Perhaps you missed it. In her personal recollections, later in life, when complaining about cheap imitations based on another of her books, Physical Geography, she noted that no one has attempted to copy my Connexion. The subjects are too difficult. Clearly, Mrs. Somerville's concept of a book on popular science, especially the physical sciences, was not exactly mainstream. However, none of this seems to have been a hindrance to her readership. Connexion ran to 10 editions. Its genesis, especially for its physical astronomy section, arose from Mary Somerville's previous publication, Mechanism of the Heavens, a monumental translation effort of an epic mathematical physics treatise, Celestial Mechanics, written by the legendary French mathematician Pierre-Simon Laplace. There's a sample page from her translation, an 1820s typesetter's nightmare. Given that she was basically self-taught in physics and mathematics, and managed to have time for 2 marriages and 6 children before its publication, this was an extraordinary intellectual achievement. By way of introduction to my copy, here are its first few pages. This is the inscription by Molly, one of Mrs. Somerville's daughters, presumably gifting the book to a friend, Robin. Molly was an informal name for Mary, as in my mother's case. Her inscription was an unexpected bonus. This is the book's title and the obligatory frontispiece. Its 1836 price was 3 shillings and 6pence. The prefaces to the first and third edition, my copy. To paraphrase the first, the book's primary purpose is to reveal the underlying unity of the physical sciences. But as further pages are turned, pencilled annotations appear on most of the pages. No margin was safe. The anonymous annotator, A2 from now on, was very probably a scholarly gentleman with a scientific background, possibly an academic or clergyman, or both, as was common in the 18th and 19th centuries. His annotations were usually courteous, occasionally approving, sometimes with an air of piety, and on more than one occasion they drew my attention to overlooked conjectures. And given Connexion was all text and no illustrations, I wouldn't have got beyond the first few subject sections without his annotations enlivening the content. Connexion captured the scientific spirit of the times, especially in the thinking of leaders in the physical sciences on the big issues, such as the origin of the solar system and the nature of light. On the origin question, Mrs. Somerville shifted from a creator, a prime mover, initiating the projection of the planets around the sun, which was in accord with Sir Isaac Newton's religious view, to a hesitant discussion of what was known as the nebula hypothesis. And I must admit, it was only the persistent annotations of A2 that brought my attention to this apparent change of heart. Each time Mrs. Somerville mentioned the planets being launched with velocity around the sun, A2 would write in the margins such things as, "Where was the planet dormant previous to its being launched into space?" Or, "This is not in accordance with Laplace's nebulous theory." Here's another example. In response to Mrs. Somerville's statement that satellites, for example the Moon, like the planets, were probably projected initially in elliptical orbits around the planets, A2's comment was, "The projectile and not the nebula hypothesis seems to be favoured by our authoress." But what is the nebula hypothesis? Well, it stated the solar system was created from a giant molecular cloud that collapsed under its own gravity to form a rotating disk of matter, leading to the central concentration, that is, the Sun. Planets also developed within the disk from the remaining material, and they all rotated in the same direction. Here's an illustration of the modern version. In 1796, Laplace, as did Immanuel Kant earlier, advanced such a model for the evolution of the solar system. Prior to Connexion, Mary Somerville had published her superb translation of Laplace's celestial mechanics, and one would think she had been aware of Laplace's nebula hypothesis, so it's surprising that she made no mention of it, and chose instead to describe the mechanism in terms of a prime mover, in accordance with Sir Isaac Newton's religious views. Well, that was until page 397, where she stated, "The hypothesis of Laplace, which he conceived to be formed by the successive condensations of a nebula, whose primeval rotation is still maintained in the rotation and revolution of the Sun, and all the bodies of the solar system in the same direction." Yet she had reservations. She required observational evidence to support the hypothesis, and that wouldn't happen until further improvements in the telescope shall enable astronomers to penetrate deeper into space. So what to make of Mrs. Somerville's views on the origin of the solar system as she transitioned from Newton's religious view to that of considering Laplace's hypothesis in the light of further observations? Well, it was a time when biblical interpretations of the universe's origins, Earth's age, the Great Flood, etc., were being challenged by astronomers and geologists, and often in the early 19th century, treatises such as Connexion often carried religious references, and the revered Newton was still influential, but it certainly had a calming effect on A2. Which brings us to the ether, a hypothetical, all-pervading, mysterious cosmic fluid called the ether was conjured to explain the radiation of light and other physical phenomena. Before reading Connexion, I'd always regarded this hypothetical cosmic fluid as a quaint, obsolete concept to which 19th century scientists paid lip service, but were dubious about its reality. Mary Somerville's book changed my perception. I learnt that for most of the 19th century, the ether was central in modelling various physical phenomena. To physicists of that period, it was intuitively obvious that light required a substance for its transmission through space, in analogy, for example, with sound propagation. As early as page 39, she had written, "If light consists in the vibrations of an elastic fluid or ether filling space, an hypothesis which accords best with observed phenomena." But the first requirement was to think of light as a wave motion. She was an ardent believer in an undulatory theory, based on light being transmitted as a wave. This was in opposition to Sir Isaac Newton's corpuscular theory, which she said imagined light to be a material substance, emitted by all self-luminous bodies in extremely minute particles, moving in straight lines with prodigious velocity. For her, Newton's theory failed because of its inadequacy in explaining optical phenomena such as diffraction and interference. This was a significant departure for Mrs. Somerville, for she held Newton in the highest regard. Here's a brief technical sketch for her interference argument, assuming the undulatory theory. Interference of light is the interaction of two identical, coherent light waves, which when selectively combined, produce patterns of light and dark intensity fringes. The light fringes correspond to the maximum possible intensity of the two waves. The dark fringes indicate zero intensity, the latter known as destructive interference. The classic experiment, demonstrating light interference, was performed by Dr. Thomas Young in approximately 1802. In this diagram, sunlight shining on a pinhole S illuminated two pinhole apertures S1 and S2. These provided the two coherent light sources. A white screen placed beyond S1 and S2 displayed the interference fringes formed from the converging waves. But as Mrs. Somerville pointed out, interpreting destructive interference with Newton's corpuscular theory, based on the flow of individual particles, is contrary to all our ideas of matter to suppose that two particles of it should annihilate one another. According to Mrs. Somerville's personal recollections, Thomas Young had proved the undulatory theory by direct experiment, but as it depended upon the hypothesis of an ethereal medium, it was not accepted in England, the more so as it was contrary to Newton's theory. But what I didn't see coming was the tails of comets offered as proof for the existence of an ether fluid. Mrs. Somerville optimistically stated the existence of such a medium, though at first hypothetical, is nearly proved by the undulatory theory of light, and rendered all but certain within a few years by the motion of comets. She assumed that a celestial body such as a comet, moving through an elastic fluid ether, would experience resistance in its trajectory, and that observations over time, which measured its orbit's period around the Sun, would reveal the ether's influence. There's a great shot of Mars and comet sighting spring. She believed the comet's passage through the ether, together with the Sun's heat radiation, melting the surface of a frozen comet as it approached it, provided evidence for the tail's shape and length. She wrote, "Two repulsive forces seem to be concerned in producing this effect, one from the comet and another from the Sun, the latter being the most powerful." And so to Mary Somerville's concluding remarks. She believed that her era was poised for profound advancements in the physical sciences, especially when analysis, that is mathematics, was included. Mrs. Somerville listed various physical phenomena, both terrestrial and celestial, which demonstrated the connections between them. Heat and light and chemical action, electricity and magnetism, the undulatory wave-like behaviour of sound, light, water, and the gravitational influence on everything. As often with those of profound intellect, her conclusion's penultimate paragraph demonstrates her prescience. She wrote, "There are many illustrations of the connection of the physical sciences, bonded by analysis, which is daily extending its empire, and will ultimately embrace almost every subject in nature and its formulae." She also predicted in her final paragraph, "These formulae of the future will condense into a few symbols the immutable laws of the universe." So, an early vision of a theory of everything? Mary Somerville died in 1872. Just 1 year later, a fellow Scot, James Clerk Maxwell, one of the greatest physicists of any century, fulfilled her prophecy, at least for classical physics, by summarising his research in the epochal treatise on electricity and magnetism, in which he unified, with a handful of equations, electromagnetism and light. There's a reference to Mrs. Somerville in his treatise. And as for the anonymous annotator, below Mrs. Somerville's final paragraph, A2 wrote a date, 10th September 1842. It was a Saturday, presumably the conclusion of his own assiduous pencilling. Once again, thank you for viewing this video.